Assalamu alaikum everybody. uh, I'm going to try and explain how to use deep learning methods to perform sentiment analysis in today's video, and for that I will be using Python, and I'll be also using some block diagrams to explain the basic idea, and finally I'll be showing you the implementation on a real data set by using convolution neural networks to perform sentiment analysis. Okay, this is the simplest of the block diagrams which you can have for a machine learning methods, and in which you can see here that there is some training data with the known labels, and then some kind of machine learning algorithms that can be as simple as naive Bayes, and can be anyone from SVM, logistic regression, and bagging, boosting, you name it. There are many, and every algorithm is not suitable for every type of data, so you have to find out which algorithm suits your data. If you look at the bottom side, the classification here, and again an unseen data, text input, and there is a model which was created after training process, and this model is going to identify and label the input text accordingly. In the simplest form, it can be positive, negative, and neutral. Here you can see the word embedding. It's the state-of-the-art method which is nowadays used to identify the words present in a text, and also identify its context and the relations. There are many things which can be done, so it's a kind of knowledge base which is used to better the accuracy of your system. Okay, before we go into the word embeddings and deep learning, the basic steps required to perform any kind of text processing is a pre-processing step in which you perform different actions on the data, like you remove the words which are not useful, like there can be a lot of garbage which are not very useful for your processing or for your results, so you remove it. Like there can be many URLs, links, special characters which you might not need it. Then there is a list known as stop word list. All the words which are not very useful, they are there for the grammatical purpose, can also be removed. Then what we do is to we transform the cases, that is from all the letters, all the characters, into small case for uniformity. And there are many other things which can be done to pre-process or clean your data. Then come the feature extraction part, in which you identify the features on which you want to work on. Then comes that classification process, and then updation of the lexicon, which can be automatic or semi-automatic. It depends, which is very useful when you are doing some kind of processing on a large data set like big data. So a big lexicon is very useful, and you can assign weights also anyway. And if you look at this side, there can be pre-processing can be done using the regular expressions, and you can also use emicons, negation tools, idiom lexicon to identify different words and weight them accordingly. Okay, if you look at this block diagram, you can clearly identify where you should be applying your deep learning methods. And for that, you can see here, if you start from the beginning on the left side, this is data exploration, and some product reviews data is being collected, and cleaning of data is performed here. Then come this embedding part. This is where you have to add this process of learning and data transformation. Word to vec is one word embedding algorithm which is very popularly used, and the other one is the globe. So you can use either of them, and from here you can use 80% for training and 20% for testing. And then comes the deep learning part, where I'll be using CNN in this video. And after the training of CNN, the model will be deployed, and then unseen data can be applied to the model, and sentiments of the text can be predicted. So this is the simple steps. Again, the question was where to apply word embeddings is this place, and where to train is this place. This is the deep learning where you are going to train it, and this is where you are going to apply the word embedding. You can also call it knowledge base. If you want to apply some kind of knowledge base, you can apply somewhere here or after this process. It's up to you. So you can try and test which is better for your data. Anyway, okay, the data set I'm going to use in this is, you can see on your screen that it has 3 columns. One is the ID, the second one is the target, and the third is the text which have been collected from Twitter. And you can collect any type of data you want. The only thing which is very important when you are collecting data is to make sure that the classes are equal. Like if you have collected 1000 of the tweets or any post, what you can do is collect exactly 500 of them, the positive ones, and the remaining 500 for negative, so that the training part can be very balanced. If you collect some kind of data which is unbalanced and the classes are not balanced, then the training will be faulty, and obviously the accuracy of your model will be downgraded. So you must have seen this kind of data many times. So this is the data that I'm going to use. In the second column you can see zeros and ones. 1 is for the positive and 0 is for negative. This data has been annotated and it's ready for using for training purposes. And you can see, I'm going to show you, there are lots and lots of text available here. Now you can see there are 31,962 tweets in this data set. So this is the data which I'm going to use. Okay, this is the actual code, and I'm going to show you how it works and tell you basics, and also tell you where to insert the word embedding code and also the CNN code and how to compare the results. So first, I am using this Colab. So what I have done is I have mounted my drive, the Google Drive, and you can see there I'm using pandas and numpy and matplotlib. Okay, so drive is mounted. Then I have imported the operating system library so that I can identify the directory where my data and the notebooks are there, and the Colab my Google Drive. and then I'm going to load my data, testing data and the trading data, and you can see the same data which I showed you earlier. Some first 5 tweets, and here I'm going to show you some ranges. As I said earlier, it has 3 columns and 31,962 rows or the tweets. Okay, here I have taken 2 variables, x and y, and my data frame dot tweet and my data frame dot label. I have imported it. Then comes the sklearn library, which is very useful for machine learning, and from there I'm going to select and just data into 2 parts, divide data into 2 parts. That's 20% for the testing and the remaining 80% for the training. And after, if you look at here, after processing, you can see the records. Alright, then I'm using this ginseng and pandas to show the progress bar, and these are some labels. On the top you can see here that I have imported word2vec and doc2vec. These are the 2 word embeddings which I'm using, and different utilities which will be needed for processing. Here you can see that I'm using the model of continuous bag of words, CBOW, and these are the parameters which are given for this word2vec model and to develop the vocabulary. You don't have to go into the details, you just need to identify the default parameters which you can use on your data set. Alright, so here is the processing, and you can see I have already done this because it is going to take around 2 hours to process this data, so I've already done it before the recording of this video. Here you can see the word2vec model processing all the 31,962. This is the second epo that took 33 minutes. Look at the bottom of your screen, it says 33 minutes. And then comes this convolution network, and here you can see that I have started with the tokenizer, and these are some parameters. Then the training sequence. I've selected this 100,000 words total out the first top frequently used 100,000 words, and this is the model training part. We have tried and used different models, and you can see here that binary cross entropy using this activation ReLU and sigmoid functions. You can test and try different functions, obviously. Okay, this is the convolution neural network layers, and you can see how complex it is, but the thing is that it has been used for like in this there are like 10 layers, and these are some sections. This is the input section, the stages 1, 2 and 3, and the classification, where you use different kind of functions. If you want to learn this how neural networks work, uh, we can do it later on sometime. Okay, after applying the convolution layer, you can see the model and the parameters, and the total trainable parameters were 20040 and all of them were used to train. If you continue, you can see here that maximum pooling, global and word embeddings are done on 200,000, and that is 20,040,100 parameters. Embedding was done on that. These again are different models. You can check it out, that CNN1, CNN2 and CNN3 models, 3 different models with different parameters were used to train the model, and the best model will be used later on for testing purpose. So this is how you can try and test with different parameters. Okay, this training process took another 30 minutes, so I've already done it. I have run 5 epochs on the 3 models. Then you can see here that I've also done this to compare the model. This is for bigram and trigram and foregram, and there is a mergegram, so that we can identify which one is good for our data. Okay, so finally what happened was that we were able to achieve this 95% plus accuracy, and it's 95,869 something. And if you check that with the TF-IDF, which was the basic method used previously when you are not using the deep learning models, you are only using the machine learning methods. So I have compared with that also and used the logistic regression algorithm for classification, and the score comes out to be 94.77, which is 1% less than the results achieved by using the deep learning methods, and which is a significant. Alright, this is the last thing which I want to show you, and this is the true positive and false positive rate, and you can see and understand the diagram. And by using so So this is how we were able to use and compare two different methods, the traditional method of TF-IDF plus logistic regression, and we were able to produce 94.77 percentage of the accuracy. And when we use this word to vec plus convolution neural network, that is deep learning, we increased the accuracy to 95.90, which is a significant step. It can also be enhanced and increased further if you add the knowledge base or perform better pre-processing steps, or train the model on more APOs. This better results can be attained, and it is very possible. So this was the basic. I know it's just an overview, but it might help you understand what to do, where to put in the knowledge base, where to add this word to vec, and from on, and where to apply these deep learning methods. I hope you must have done something out of it. Thank you very much.